Okay, I'm going to explain to you all you need to know for the test tomorrow. Here goes. First of all, speed is distance divided by time. And if you like triangles, that looks like this. Speed is distance divided by time, or if we're going to rearrange it, distance is speed times time, time is distance divided by speed. If I want to be a bit more precise, we should say average speed, because as we'll see, sometimes the speed can change. So that's the first little thing you need to know. Now let's think about motion by looking at graphs. Suppose I've got my dog, here's his kennel, and he's sitting here, just outside the kennel. At a certain distance, which we'll call D. And let's suppose he's not doing anything, so he's just sitting still outside his kennel. Let's put that on a graph. He's got a fixed distance, he doesn't move anywhere, so on the distance time graph it will look like this. At every point in time he's the same distance away from where he was at the start. Now let's suppose that he starts moving away from the kennel. Maybe he's chasing a ball or something. This time his distance is going to get bigger, so the graph is going to look like that. If he goes really quickly, chasing a squirrel maybe, then the distance is going to get bigger really quickly, and so we can see that the slope of the distance time graph tells us about his speed. And in fact, if we measure the gradient of that graph, the rise over the run, that will give us the speed. So speed is the gradient of a distance time graph. Okay, to get the speed from a graph of distance time, just measure the gradient. Now one third case. Let's look at the case where here he is with his kennel. And this time he's seen a squirrel and he wants to chase it, so he's going to accelerate away from the kennel. What would acceleration look like on a distance time graph? Well, pretty obviously he's getting quicker. So the slope gets steeper, the speed gets bigger, he's accelerating. If we wanted to show that on a velocity time graph, what we have to show is the velocity getting bigger. So on a velocity time graph, maybe he starts, he's not moving, so his velocity is 0, but as he's chasing the squirrel, his velocity gets bigger. So that is what we call acceleration, getting a bigger and bigger speed as time goes by. Acceleration, the formula for acceleration is the change in your velocity divided by the time taken to change. So it's a measure of how quickly you're speeding up. If we draw that as a triangle, acceleration is the change in your velocity divided by the time taken. This little delta symbol there just means change in. The little Greek delta just represents a change in velocity. So acceleration is the change in velocity per second, the change in velocity divided by the time taken. Units were a little bit odd. We measure it in meters per second or meters per second squared. Okay, so we can measure that from the graph as well, because if you think about it, if we go from this point to this point, there's a certain change in time and a certain change in velocity. So that, the rise over the run, will give us the acceleration. So the next thing you need to know is that acceleration can be measured from the gradient of a velocity time graph. Okay, so we've had so far speed is distance divided by time. We've worked out that you can measure the speed from the gradient of a distance time graph, and now we've just seen that you can measure acceleration from the gradient of a velocity time graph. One final quick point: if we have, again, an object that's accelerating like this, let's say, so the velocity is getting bigger, and let's say we look at the first few seconds of the motion, this area under the graph tells us the distance that you've travelled. So the area under a velocity time graph equals distance travelled. Okay? And that's pretty much all you need to know about motion time graphs. So let's quick recap of those basic facts. Number one, speed equals distance travelled divided by time taken. If you want the triangle, speed is distance divided by time. Number two, velocity can be measured off a graph by looking at the gradient of a distance time graph. Number three, acceleration, which is change in velocity divided by time taken. That can be shown with a triangle like this: change in velocity divided by time taken, and that's equal to the gradient of a velocity time graph. And the very final fact is that the area under a velocity time graph tells you the distance travelled. So that's really it. Speed is distance divided by time, velocity is the gradient of a distance time graph, acceleration is the gradient of a velocity time graph, and the area under a velocity time graph tells you the distance travelled. That's all you need to know about motion graphs.